Alright, are the figures congruent? So in our warm-up, the very first picture, these are those nesting dolls, I think they're called. Yeah, the little Russian dolls. I think they're called nesting dolls or something like that. So if I look at them, the question is, are these congruent? Okay, I heard. Yeah, no. What do we think? Are these congruent? I'm also awarding out on our Starbucks. That's what I've been doing all day. So, what do we think? Are these congruent? Why or why not? Blake?
No, because they're like smaller than each other.
And what's that mean? What does that matter?
That they're different.
Okay, so what's it mean to be congruent?
I don't know. Exactly the same.
What, Damari?
Exactly the same.
So, Blake, you're right. These are not congruent.
Different sizes.
Because they look the same, but they're smaller. So they're smaller, which means that they are not congruent. Damari just said congruent means you have to be exactly the same. When we talked about congruent yesterday, same size, same shape. So if they look the same but they're smaller or bigger, that means they are not congruent. Same thing, when we look at this car picture, this is like a model car. Has anyone ever put together like a model car? I've done ones before where I made a little pickup. And on the box, it was telling me like it's, I don't remember the exact measurement, but it said the scale was like 1 to 64. You know what that means?
How much smaller?
How much smaller? Yeah, they said for every 1, if I measure something like that tire, if it's 1, the real tire is 64 times as big. So they're giving us our scale. It's saying that everything should be the exact replica. Everything should look exactly the same. It's just a lot smaller. When we did a translation yesterday, or we did a reflection, or we did a rotation, did we change the size or shape of the items? Did we change the size or shape? No. So the first thing is no. When we did translations, reflections, and rotations, our shape stayed the same size, same shape. We just changed its location. What are those 3 things called? What was that vocabulary word that we had yesterday? What's that called when we do translations, reflections, rotations, and they do not change our shape or size? No, they are congruent. You're right. You're totally right. They are congruent. But what is that? What was that called when we did congruent? When we moved? No, they are transformations. There you go. Rigid motions are going to be our translations, reflections, and rotations that we do that do not change our shape at all. When you go to an eye doctor, actually my wife, she might be going here right after school, and she wanted me to go. And when I go, they dilate your eyes. Well, when they dilate your eyes, if you've ever done that before, they put those little eye drops in, and if you look on her picture, what did it do to the one pupil? It made it bigger. So when we dilate something, we're making it a lot larger. And so, do the shape of your eyes change when they dilated them?
No.
Well, did the pupil change? Yeah, the shape itself stayed the same. The shape stayed the same, but the size changed. So we didn't change the shape. And this is what we're going to work on today. It says, I can dilate figures in a coordinate plane. We are going to be changing the size of a shape today. That's going to be our biggest focus. Now, I am going to show you this explanation. You're going to work for about 5-10 minutes, and then I'm going to be giving out Starbucks for our answers, what you ended up getting. If you're messing around not doing this, I'll just mark you down. But, right now, on your sheet, everyone should be looking at this sheet. Looks like this. And I'm going to fill out just a piece of it with you. the first thing is that we have to record the coordinates. So I want you to tell me that A is at 1, 1, B is located at 5, 3, and C is located at 5, 1. And I'll show you where I'm getting it. But I want everyone to make sure they're writing that down on the little folder. Then on number 2 it says change the scale factor to 2. You're still going to use the original triangle shape. So on this number 2 I want us to put down. Yeah. Alright, so here's what you are going to be spending some time doing with partners at your desk as long as you're focusing. If I come around and you don't have much done, like I said, I will be marking you down because you're just wasting time. You're not doing anything mathematically. We are going to go to this website. You're all going to get to go there. On this website, oh, I closed it. When I go to this website, it's looking like this. Here's our starting triangle. On this starting triangle, this is where I got my coordinates. A was at 1, 1, B was at 5, 3, C was at 5, 1. Ricky, you're in this spot. Okay, because you're not paying attention. Next time I will move you with the mark. Colin, I don't need to hear your comments on this either. Okay, here's our scale. This is what you're going to click and you're going to move, and you'll see it's going to change our triangle in a certain way. Your goal is going to be through this activity that you understand what scale means and how we can identify the new coordinates with the scale without drawing, without having the computer, because you're going to have to do that for you. You can use the computer right now to visually see and make those changes. So, here's what I'm going to give you about 10 minutes to work on. You need to open up your OneNote. You go to 2.5 Dilations, and you'll see, if you scroll down to the exploration, here is the website link. Go ahead and you'll be able to click on it. And then I want you to work, and you need to answer 1 all the way through the bonus. So the 2 pages in your notebook. 2.5, both sides. 1 through bonus. Okay. Who can tell me, based off this work, we had an original, I was supposed to change the scale to 2. So I did that. What's the first thing you notice? What did increasing the scale from 1 to 2, what did that do? It made my triangle, bigger. Here's an important part that you guys want to know. We want to make sure that our scale is always starting at 1. When we have our original, we're going to start at 1. That's going to be important. So when I went to 2, it got bigger. What if I would have changed the scale to 15? Would it have got bigger, smaller, stayed the same? It would have got bigger. It would have got larger. So for my Starbucks, who can tell me what, when I went ahead and did this, you guys, everyone should have this answer because it was on the computer. What were my new coordinates for A? This is A. Remember, A with that little tick mark means the image of A. What were the new coordinates? Where's my phone? Bryce. Hey, it would have been 2, 2. What was B?
I got 10, 6.
It would have been 10, 6.
And 10, 3. Oh my god, I did it right. That's what I got. 10, 2. 10, 2, I mean, sorry.
Should be 10, 2. Alright. Okay, what operation, so this one, what operation should you use to change triangle ABC to the image of ABC by a scale factor of 2? our scale was 2. Tyler? Good. We are going to multiply by 2. Now, here was the important part. What we were doing, we were using this image that we just used on Chrome, this little website, to visually see where our coordinates changed from. But now we should have been able to think about this and said, okay, when I change my scale to 2 and I compare my coordinates, that they face forward and don't be turned around there. And I see that they went from 1 to 2, 5 to 10, 5 to 10, 1 to 2, 3 to 6, 1 to 2. I see that I multiplied by 2. If you put this down, this would be helpful. This is going to be what's going to be put on your test. But I'm going to say X represents my scale. If X, our scale, is larger than 1, our image will become bigger. We will increase the size of our image if our scale is larger than 1. And that makes sense because 1 is the original size. So if I look at number 3, to be honest, I shouldn't have had to even use my computer. I should have been able to save time. What would be my new coordinate points if my scale factor was 3? Cohen? Nope. Tyler? Dylan? Okay, would have been 3, 3. Perfect.
Good job.
What operation would you have used when the scale factor was 3? Natalie? We multiply by 3. We should have, right now, understanding, we multiply by whatever our scale factor is. So number 4, Andrew, turn around. On number 4, we still have our 1, 1, 5, 3, 5, 1. Go. This is your last warning. You're just being distracted and making noises. Hold it in. On number 4, our scale factor is 0.5. Is my shape going to get bigger or smaller?
Smaller.
Why smaller?
I didn't hear shape.
Okay. Okay. It is going to get smaller because 0.5 is less than 1. So if we ever have our scale being less than 1, our image will get smaller. Now I'm going to go down. No, I'm going to leave this part. So what would be my answer first for my Starbucks? What will become my answer on this? If A was 1, 1, 5, 3, 5, 1. All right, Tyler? Say what would be? 2.5, 1.5. So what was my operation I should have used? Brian, do you need something? Okay, then let's pay attention to this. What would have been my operation we would have used to find those 3 answers? Colin? We would have multiplied by what?
2.5? You said 2.5.
Bryce?
0.5.
Okay, multiplied by 0.5. Now, here's the trick, and we have to get used to this. We could have multiplied by the decimal 0.5, but we know 0.5 is also equal to the fraction 1/2. So we could have multiplied by a fraction 1/2. When we get into our algebra and you guys continue your math career, you're going to find out that sometimes I don't want to multiply by a decimal. I need to multiply fractions. 0.5 is the same as multiplying by the fraction 1/2. Because 0.5 is a half. Now, instead of multiplying by half, you could have also divided by 2. Taking a half of something is the same as dividing by 2. All three of these are all equivalent. Times by 0.5, times by 1/2, divided by 2. You need to get comfortable with those. The biggest thing was we multiplied by our scale factor. Our scale factor was 0.5, so we multiplied by it. So here's one of the bonuses. If we changed our scale factor to -2, first question, is my shape going to get bigger or smaller?
Bigger.
It's going to get bigger. Because we are going to look at what is the absolute value of my scale. It's a -2, but I don't care. It's a 2. Is a 2 bigger or more than 1? Bigger or smaller than 1? 2 is bigger than 1. So, if you had went to here and we look, there's our scale of -2. That new triangle, that image, is twice as big. It's still not twice as big. Did it move it though? Okay, because the negative sign, get used to this, negative, right here, that negative sign has kind of two meanings. It's negative, or it's also the opposite of. So when I multiply by -2 for my scale factor, my image got twice as big, but everything got reversed. So when I looked at my first coordinate points, 1, 1, 5, 3, 5, 1, if I multiply by -2, we've got -2, -2, -10, -6, -10, -2. And if we look at this, what happens is that -2, it changed everything. When we multiply by that -2 for our scale, when we're changing our scale, it's going to reverse everything, which means it's going to do a 180. You guys ever talk about 180s, Riley, with skateboarding, and you guys do a 180, you face the opposite way, right? So if you do a 180, this went from coordinate 1 to the opposite of coordinate 1, which is coordinate 3. You could also think that it went 1, 2 jumps. Now, if it does -3, is it going to do 3 jumps? No. The 3 shows how much bigger it is. It's going to be 3 times big. The negative means opposite. So it would still go to the opposite one. If my triangle, I'm going to go ahead and do this. We're at -2, right? So if my triangle was moved to over here, I put it in quadrant 2. It's in quadrant 2. There's all the points. If I took it times -2, the new triangle is twice as big, but it's also 180. It's in the opposite quadrant. This is 2, the opposite is 4. 1 and 3 are opposite, 2 and 4 quadrants are opposite. Okay? Let's see, what do I... So, that's the biggest thing we're going to look at today. I'm going to show you your homework and give you one of the answers.
Let's go.
So, your homework for tomorrow. Pretty simple. I totally expect everyone to have this done. On numbers 6, 7, and 8, describe the relationships between the given point and point A of being 8, 12. So, should not have people talking. Go in. I want you to focus up here so you know what to do for homework. If A is 8, 12, and B came out to be 16, 24, you're going to say this is the answer. You're going to say my scale was 2, which meant to get from 18 or from 8 to 12 all the way to 16 to 24, I times it by 2. So on 7 and 8, you have to tell me what was the scale. It was at 8, 12, and now it became 2, 3. How did I get there? You're going to be telling me my scale. On 9 through 14, it's a yes or no. Is this a dilation? That's your homework. Due tomorrow.